Simcision provides helpful tools to understand the dynamics and relations in your model. Let's have a look at those. The analysis features become useful as soon as you have a model with a few relations. I will be using one of our available example models for this demo. In the Analysis tab, we have two sub-tabs, which each contain individual tools. Let's start with a cross-impact matrix. This tool is very useful for models with many impact relations, like this one. The matrix lists all elements of a model positioned along two axes. The labels allow you to associate the element in the model. You can also hover over the markers to see the connected element's name. Let's look at the axes. On the horizontal side, we look at the active influence of each element. This value comes from all the outgoing relations of each element. We look at their strengths, add those up, and position the elements relatively. The elements on the right-hand side have a lot of influence on the model. The elements on the left-hand side do not have a large effect. The vertical axis orders the elements by influenceability. The more and stronger incoming relations affect an element, the higher it will be listed in the matrix. The elements on the bottom are hardly influenced by other variables in the model. These positions allow us to see at a glance which role each factor plays in our model. Buffering elements hardly influence other elements and are not easily influenced by other elements either. The values of these elements will stay rather stable. Active elements are not easily influenced themselves, but any change in those will have a larger impact on the state of a model. These are levers to concentrate on if you want to influence the state of a model as a whole. Passive elements don't exert much power on the other elements of a model, but are very dependent on other element states. These are prime candidates to affect through indirect relation effects. If the other element values change, these elements will be changed along. Critical elements are both highly dependent on other elements' values and also exert a lot of influence on the state of the model themselves. Be on the lookout for changes to the model that affect these elements, or elements that affect these, since those will spread across the model. As a rule of thumb, you have to pay attention to the passive and critical elements if you need to maintain the stability of a model, and concentrate on the active and critical elements to reach the highest impact. This matrix is very useful if you use it during a simulation. There are two modes of calculation to determine the active and passive values. One is static, using the maximum amplitude of strength of each relation as a base. The other one uses the current slope of the influence curve of each relation as a base, and that value can change during a simulation. This way you can check which elements are the most influential at each point in time. You can load a simulation here. This field is connected to the simulations area. The active simulation is always open there. When moving through the rounds, you will see the elements' positions change in the matrix. When no simulation is loaded, you can also change individual elements' values of your model temporarily here, to see what effect this has on the matrix. Showing all target elements and their effect through impact relations is a matrix default. You may also change this and create your custom matrix configuration, including a subset of elements. You can also switch the matrix mode to a flow matrix. This is a matrix mode built for system dynamic models that heavily use Stockholm flows. Since we have no flow relations in the loaded model, it won't show us anything. So let me switch to a different model to show you the value of this matrix. Okay, here we've got a model with some flows. What we see in the matrix right now are all the elements that are connected to flow relations. The farther to the right the element marker is positioned here, the larger is its outflow through its flow relations, compared to its current value. The farther to the top the marker is positioned, the larger is the element's inflow compared to its maximum capacity. So, as long as these elements are positioned along the diagonal line, their inflows and outflows are balanced out, any element positioned below the diagonal line is emptying out. Elements above the line are filling up. The closer one marker is positioned to the outer border, the closer the element is to be completely filled up or emptied out. As you can see, the flow matrix provides a fast overview of the current states of your elements affected by flows. That's it for the flow matrix. Great. I believe that we covered the main parts of the matrix tab. Let's switch to the other sub-tab now. And we will return to the impact relation model we had opened earlier. The impact chains tab is built for these kind of models. It won't help you with stock and flow models at the moment. In this tab, we have tools to better understand how the elements of this model are connected via relations. The first tool is Ways and Cycles. It can show you all the direct and indirect ways an element can affect another in the model. Select a starting element and an end element, and you will see a list of all possible connections between those two nodes. As you can see, there are a lot of ways that a value change can spread through relations in this model. Seeing all of these connections and their strengths can help you check the validity of your model so far. Are all connection paths valid and correct? Do the stories make sense? And are there connections that might be redundant because they are already modeled indirectly? You can also use a tool to see all loops that an element is part of by selecting the same element as start and end element. The small icon next to each loop will show you if a loop is balancing or reinforcing. Lastly, in the impulse tracking tool, you can check how an impulse will be transmitted through the relations of a connection path. Create a new impact chain and select the starting element. We can now set an impulse on this element. The impulse represents a change in value of a starting element. We can now see how this change travels along in a chain of impact relations. In the model, the marked relations highlight the next possible elements in the chain. These are the elements connected by an outgoing relation. When you select the next element, it will be added to the connection path, and the derived impulse is calculated. Since the connecting relation has a strength of 30%, the second element in the chain will only increase by 6%. You can add elements to the chain indefinitely. Using this tool, it's easy to see how strongly an impulse will indirectly affect connected elements. By the way, the two tools in this tab are connected. When you found an interesting relationship path in the Ways and Cycles tool, click on it to open it up in the impulse tracking view. It's pretty fast to find out the strength of a way or loop using this shortcut. Now you should have a pretty good overview of the Analysis tab. The tools in this section will help you out greatly if you're working with a model with many impact relationships, such as this one. Use them to reflect on your relationship connections and their strengths. Thanks for watching. If you haven't seen all of the other tutorial videos of simcision, do it now. Check them out. I recommend those. They serve as a great first deep dive into the features of the software. See you next time. And remember, every model is wrong, but yours might be useful.